Hey there, Dodd Middle School. How you doing today? Hope you're doing well. Let's take a moment to just recap some of the things that you have recently learned, like chromosomes. What chromosomes are made of is your genes. And what are your genes made of? It's the DNA. And that is what you're inheriting from your parents that come out in you like a trait, like your eye color or your height or whether or not you have freckles. These are all traits that we inherit from one or both of our parents. So in total, what you guys got from your parents is 46 chromosomes. 23 chromosomes from your mother as her version of who you can be, and then your dad gave another 23 chromosomes from his version of who you might be. And together they created a blend, half of mom and half from dad. And that's kind of a summary of some of the things that we had learned about. And so let's move forward a slide. Okay. So for here, the point we really want to get a little bit deeper into is the idea that your parents have parents too. And so when your parents gave you traits from them, they either gave you their mother's version of their trait or their father's version of the trait. And so you are really inheriting either your grandmother or your grandfather's version of a trait from each of your parents. Does that make sense? It's a little bit confusing, but I think we'll get more clear as this goes on. And so one thing we're going to look at with genes is when genes come together from two different people, they may react in different ways. Sometimes they may blend together, where it could be a blend of the difference between the extremes. That's called incomplete dominance, where perhaps it's a skin color or a hair color that lies between the two colors of the mother and the father. You could also have something called codominance, where both genes end up showing up in the child. This can happen sometimes with blood type. If the mom was type A and the dad was type B, there is a chance that the child might have blood type AB instead of A or B. And so sometimes genes do blend together to make a kind of compromise between the two. But other times, genes will overpower or dominate the other one, and one of the two genes won't show at all. It's still a gene on one of the 46 chromosomes your parents gave you, but it might not show in your traits. And so that difference is called a dominant gene, the stronger one, versus a recessive gene, which is the weaker one. And so that's what we're going to kind of concentrate on for this portion of the genetics, is the concept of how the interplay of dominant versus recessive could create some interesting offspring as the generations move on, all right? And so here's an example of that. So on this slide here, I want you to take a look at the parents. Here's mom, here's dad, here's baby, okay? You can see a few characteristics about the parents and see that maybe the baby has some resemblance there. But is there something in the blending of these faces that doesn't quite seem possible with this child? What I mean by that is take a look at the skin. Does the skin color seem like it could be something that came from these parents? Or the hair color? Or maybe the eye color? And so what I want you to look for here is there anything that doesn't seem like it could be in the DNA of the parents, yet you see it in the child? So, to help us understand it a little bit more, we're going to send it over to Dr. Dublin, who has a little bit of a demonstration for us.
Oh, hello, Dodd Middle School. It's Dr. Jean Dublin back here again for you. Today, it's time for you to learn a little bit about dominant and recessive genes. So, Mrs. Seymour left you with a question. What seems unusual about the blending of genes from these two parents? Is it their skin? Well, their skin of the baby seems between the skin of the mother and the father. So this is like an incomplete dominance, a blend of the two colors. So no, that seems okay to me, okay? The hair. Well, this baby's hair is dark, probably darker like daddy's, but still seems reasonable to me. The eye color. No blue in the mama, no blue in the papa, but we got blue in the baby. Something very unusual about that. So, let's reveal the concept of the day. Brown is dominant for eye color over blue. Now there are other genes that can influence eye color, but we're gonna stick with a traditional example. Brown is a dominant eye color over blue. Both of these parents have brown eyes. They got their brown eyes from their parents. And so therefore, each of them has 2 genes for eye color. Perhaps we know that since brown is dominant, they must both have at least 1 brown gene from their parents. So maybe this brown came from a mama, and maybe this brown came from his mama. But they also got a gene from their papa. And so therefore, did papa give them brown? Because if they gave them brown, then they are a purebred brown. Put that up there, stick there just fine. Okay, this would be a purebred brown, meaning mama and a papa gave this a mama both brown eyes. This dada got his brown eyes from both a mama and his a papa. However, is that the only way these parents got brown eyes? Oh, no, 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 no. So therefore, is it possible that this mama got brown eyes from her mama, but blue eyes from daddy? Would she still have brown eyes? Yes, she would. She would still have brown eyes. Her genes still have some blue eyes, even though you look at her and you see brown eyes. The blue eyes don't show because the brown is dominant over it. So what if the same thing happened over here? What if this papa has brown eyes, but one of his parents gave him a blue eyes? We still see the brown, but hidden underneath in his genes are some blue. This opens up some possibilities. So when a this mother and a this father have a children together, they each will randomly give one of the gene eye colors to their child. They could give the brown or they could give the blue. Each one gives a 1 to the baby. So, if any one of the parents gives a brown, it's dominant. So this baby will have a brown eyes, whether or not it gets brown from daddy or blue from daddy. This would be a brown-eyed child, just like his parents. However, what if by random choice, mama and a papa give up both the blue genes that they don't show but they carry? Then, and only then, can we get a blue-eyed baby from the brown-eyed parents. It is because the baby only inherited the recessive genes from both parents. There is no brown gene given to this baby, so blue is the only thing that can show through. Where the baby inherits both the blue recessive from the mama and the blue recessive from the daddy, can we get a blue-eyed baby? Does that make sense? I hope so. So we're going to send this back to Mrs. Seymour, who will get into a little bit easier method of organizing these traits and determining the probability of having certain traits be passed on. Nice to see you, and have a wonderful day. Bye-bye.
Dr. Dublin, exactly the point. You would not think that we could get a blue-eyed baby from 2 brown-eyed parents. But if they are both carrying a recessive trait that isn't visible, they could both pass it on to their baby. And so in this case, that's what would have happened. So let's take a look at it from this direction, because you guys are going to take this and learn a little bit about on how we can organize these traits into a way where you can predict the probability of certain traits appearing in the next generation of any species, okay? And so this is something called Punnett squares. You guys are going to see a little bit about this in the document that you're going to have. These clips, one of them's kind of old, but they both do a really, really good job of showing you what it is we're trying to get you to learn about, something called Punnett squares. And Punnett squares are really a way to take a trait from a mother and a father and organize them in such a way where you can see the possible outcome of each of the choices that the parents might give the next generation. All right? And so, in other words here, if this was mom and dad, remember they had brown eyes, but they both carried a recessive blue. And so this might be right here, mom's genotype. She has brown from one parent and blue from another. And dad over here has brown from one parent and blue from another. And so what we're doing in this Punnett square, which you're going to learn a little bit more about, so you don't have to follow this all right yet, okay? But what we're doing is saying mom could give a brown or she could give a blue. And dad could give a brown or could give a blue. And so therefore, if this represented a child, if he inherits the brown from mom and the brown from dad, he's going to end up getting two brown dominant genes and won't even be able to grow up and have a child with blue eyes because he can't give that child a recessive blue. But all of the other ones, all of the other combinations do have recessive blues. And so these children, as they grow up, can have children that might have blue eyes because they still carry it. And only one of these three children actually has blue eyes. Do you know which one it is? I bet you do. Okay, it's the one right here with two recessive blues. And that is why this child has blue eyes. However, these two brown-eyed children still have the ability to produce the next generation having blue eyes. Make sense? Hope so. All right, so what you guys are going to kind of wrap this up with is understanding that there's really a difference between perhaps the way you look versus what your genes still hold inside of them. The technical term for it is phenotype. Phenotype is how you look. You have brown eyes. That is your phenotype. However, there are two genotypes for that phenotype. You could be a BB, which is purebred brown-eyed, or you could be big B little e, which is still brown-eyed, but has a blue recessive gene in there. So that's two different genotypes that both produce the color brown, and that brown color is the phenotype. Does that make sense? Well, whether or not it does, when you guys head on into this document, you're going to find it's going to walk you through a couple of steps that I think is going to make this so much clearer for you all. Don't forget, we're here for questions for you and anything else you might need from us. And so we hope you guys are having a good time. We miss you all dearly, and we're going to keep plugging away at this for as long as we can. All right, so miss you guys. Bye-bye.